All right, so this is what we're talking about the map and reduce. I'm not sure if my voice is heard or it's far. If I bring here, maybe it will be quite correct because I noticed some of the transcript or some of the typing there, it's quite wrong because of being far. If you try to catch me through reading the subtitles, and I say like that, sometimes it gives wrong because I'm far. The prediction is quite different. So here I was mentioning that the mapper and the class or MapReduce was the foundation of processing in Hadoop version 1. I write here. The main part for this one, this was what? This was to mention like MapReduce was the only one which Hadoop 1x or Hadoop version 1 has used for data processing. Okay, data processing. And that data processing, it was having MapReduce has two main classes, right? Two main classes. Number one is a mapper. Number two is a reducer. Number two is a reducer. So the mapper class, this divides or breaks the large file into key pair. Okay, key pair. Key pair means key values. Here is a key value. This is a key value. During the quiz, I asked you the example. Give me an example for MapReduce, just for your understanding. You can even give the one which I'm giving as mapper, for example, the name Scott. You want to map it. So remember, we use the native language of MapReduce is Java. We can write classes in Python and use streaming to translate any language to the native language of Hadoop or distributed Hadoop. So the name Scott was Scott. For example, we want to count. This is like the one which you're doing here is like hello world in big data. Hello world, you know, is the first program which everybody has to learn in a programming or in a programming language. So here, this is like counter or count the number of letters or the vowels which you have. So here we have a name Scott. We want to make in a form of key pair. Take an example. S is a key. 1 is a value. T is a key. 1 is a value. O is a key. 1 is a value. T is a key. 1 is a value. T is a key. 1 is a value. That is the mapper class. If we put in a simple words, the mapper class does what? Assign 1 to every, let's say, to every file or to every letter which we have here. That's a mapper class. The reducer class does the following. The reducer class check the letters which are similar and they combine them. For example, here we have only one S. That's why we still have 1. We have one letter T, right? I mean, one letter C. That's why I have 1. Coming to O, we have one letter O, 1. Coming to T for the reducer, we have a 2 T's. So the reducer is going to take 2. Combine and give you 2, right? So this is the work of reducer. It ends here because we had only Scott. So it reduces them. Let's say we had one more, let's say Scott, let's say For example, it was a sentence. Let's say the input was like this. Let's say this is input. We have the input. Let's say the input which we had was, sorry, the input which we had here was as follows. Let's say Scott from Scotland, right? Let's say Scott from Scotland. This is the word which we have here. I can even put one more here, say Mr. Scott is from Scotland, right? We have Mr. Scott from Scotland. Now here in our mapper, we take I, 1, S, 1. And then we have from, F, 1, R, 1, O, comma, 1, M, comma, 1. These are the Scott is from Scotland. If I want, I can put even Mr. For example, from the top we have M, 1, R, 1. If you don't write the program proper, this R will have a dot like this because it considers one word. Okay? So we have Mr. Scott is from Scotland. You can write them now. Now this is a mapper. Reducer. Reducer, we take that one. Now we look here. We look to the Scott. Now, how many T's do we have there? We have only, okay, that's correct. And then we look O. How many O's are there? 1 is here. 2 is here. Yeah, 2 are there. So we have a 2 O's. Now here, O's are going to be 2. Right? S. We have 1 S, 2 S, 2 S. So S is going to be 2. C. How many C's? We have only 1 C. 1. Now we look to O. We mentioned 2 O's, right? We have a 2 O's, 1 and 2. Now next one, T. We have a 2 T. And what about I? We have only 1 I, right? Only 1 I. And what about, I think that's all. We have another letter there, R. We have R. R is from, yes, we have a 2 R. 1 here and another one here, 2. Okay, we have a 2. So this is the reducer. This is the reducer class. So reducer is going to combine the key values. So in Hadoop version 1, this was built. Sorry, this was Hadoop version 1. All right, so where is it? This is Hadoop version 1. This is the input which you have, and this is going to map it, and then partition, combine them to make, reducer. Okay, to make the reducer part in this part here. Remember, we have also sorted. Remember when we pipeline, we take cat input mapper class like this way. If I mention here, just for your reference here, let me exit here. Remember the class name is what? Scott, right? I mean the input is Scott. So I exit this one. I save. Let's say we want to use the mapper. What do? We take input, or we take cat. What was that one? Scott. And then we pipeline. Sorry, we pipeline. We put mapper class. py. We pipeline. Sort. We pipeline. Reducer class, right? Reducer py. This is what we did. We wrote map and reduce classes just to help us to achieve this. So in Hadoop version 1, This was the main part. MapReduce used to do this processing alone. Take care of HDFS, take care of all other clients which can come. But in Hadoop version 2 plus, remember, for example, if I do this one, Hadoop version, okay, now it's Hadoop version 3, which I'm executing. In Hadoop version 2 plus, we no longer depend on MapReduce. What we do, we depend on YAL, yet another resource negotiator, to accept different tools, okay, to accept different tools. For example, if you come to, let me run this one. There's one more one which I want to teach you, but I don't know if you'll be able to run it. Houghton Sandbox, very wonderful, very wonderful, very wonderful, very latest one, okay? But it depends by the way we are moving. Okay. So I gave you two versions. The one which I gave you here, CentOS, it is Hadoop version 2, okay, in all the versions. Now we are in Hadoop 3, so it keeps increasing versions. So in Hadoop version 2, let's see, maybe we can see the version of the Hadoop and see if it is the 2 or 1, just to emphasize on what we're looking here. Okay. Now, when it came here, this is whenever you see YAL, you need to understand that this is what? Hadoop version 2, plus X. It's a next version, right? So this is next version. So this was the mapper slave. Look here. I think it shows this research, makes more clear. Let me download it and see. Okay, I think this is downloaded. Yeah, this is also a mapper they've used for the version 1. Everything depends on master, MapReduce, okay, name node, and job tracker to assign to to schedule. There's something we need to understand called the scheduling, checking the heartbeat. All this was done here. Just for here, let's look here. So this is CentOS. Let's see the version of this one. Okay, so this is the one which we did in our previous class, or the beginning of it, the beginning of the class. If I open this terminal and I say Hadoop version, we can see this is a 2.6, and which is a Cloudera Houghton. They're using Cloudera Houghton here. This is Hadoop version 2. So as you can see, the version was quite raw. If it is a version 2, means this can support, let's say, if you run JPS, that's not sure. Let's see if it will start all of them. Since this is a building, does not this is a Hadoop version 2, okay, does not allow, because Hadoop is already built in, right? For example, this is a building. If I want to move, for example, HDFS, DFS, LS, okay. So this is built in. I don't need to start the daemons, right? So it's a version 2. That was the purpose of looking what version of Hadoop which we have here, which means it supports YAL. Okay. So coming back here, this was the Hadoop version 1. no YAL. Hadoop version 2 supports YAL. Okay, so here 2 plus 2 point something 0.6. All right, so this is it. No, that's not shown there. Okay, this is easy to understand for you to get it. Okay, so this is the YAR, right? This is the YAR. YAR is here. Yet another resource negotiator. Look what is there. It's going to do job scheduling and resource manager. Job scheduling and resource manager. If you come here, you do JPS, you will see this. Now your first assignment is, what is the use of resource manager? Node manager. Okay, node manager. Node manager will act as a data node on YAL. This YAL, it supports cluster, means you have a cluster of computers. YAL is the best. But remember, we are only using one machine, only one. We don't have a cluster. That's why we depend on a name node, data node. On the cluster, YAL is the first. YAL supports so many tools there. Okay, YAL supports so many tools. It's a latest version to reduce the burden of MapReduce. Clear? I think I just roughly explained what we have here. Resource manager for job scheduling, node manager for assigning, for it works like data node, like a slave data node. Okay, job tracker, right? Job task will be taken here. Job tracker will be in resource manager. Okay, or task tracker. You may call it a task tracker. You know, task tracker, scheduling, heartbeat, resource manager will take care of it. Is it clear? Comprehensive? Can I go next? You get it? You get the concept of what we have seen, what we have here. This is what we have here. Before I go to Pig once again and look what we did. Clear? Any doubt? No doubt, right? Okay. Now, coming to our Pig. Coming to the Pig, which we have seen in the last class, we saw that we want to do analysis. We want to perform data analysis on HDFS or on local machine. I'll repeat once again. We want to perform data analysis. I'll write here as here. We want to perform data analysis on local or HDFS system, right? Storage. There are two ways. So if you want to perform this analysis, we need let's say we need a framework or a tool to enable us to enable us perform analysis on large data set. And if you have seen, Pig supports Pig, it can support structure and structured data, right? It can support them in terms of analysis. So we have seen, if you want to start Pig, for example, for instance, if your Hadoop is not running, then the Pig, it may not start. You need to check if your GPS, if all daemons are running. If they are not, pig may not start. Okay? So to start, we can do in two ways. We have seen if you do pig only, this one, this is for executing pig on top of what? On top of HDFS. Okay, or what can we do? Oh, already I executed. Gunshot. I quit it once again. Or what we can do, we execute in this way, pig -x local on the top of HDFS, or we call this map reduce, right? Sorry, here map reduce. So combine what we looked. Processing which map reduce could not be able to achieve is going to be done by what? By a pig. Because a pig can group. Pig can perform the things which query language can do. Okay, that's why we need to use pig to make more process on large data set. So here on the top of HDFS or map reduce. Okay, so if you do this, then it's going to run on top of HDFS. Two mode, right? Either pig by default, it's going to run on top of HDFS. Check here what I'm saying. You come here and you come here, you say localhost 9870. You can check your HDFS here, the status of it. So any file which you create will come here. So if you want to execute pig -x MapReduce means your data is here. It's on HDFS. Pig -x local. Your data is residing in your local disk. So here, once again, I come here, quit. Now we start pig x local. Okay. Now we execute this on the top of what? On the top of local machine. In this part, just for your clarification, whenever you run your pig, that folder or that part you don't need to specify the entire part to access your file. I repeat once again. Let's take an example. Your file, which is called student-data, is residing on home/Hadoop. If you run pig in that area, that part, you don't need to specify the part again. You can access it from there. Okay? So we are here for revision from the pig. We saw that to make any analysis, a data set need to be loaded. I take from here, I load in a pig for process, right? For process. Go with me here. Let us open one file here. And let's see. Let me increase the size for this one. You say, nano, I'm going to say student, and I'm going to say here, one, door, I say, Rwanda, two, Kenya, Myanmar, three, South 4, then I give 5 and over. Then put in here 6 breaks 7 zoo China and 8 clean Malaysia 9 Scott Malaysia. I put 10 Mario Indonesia. I put 11. I say I'm gonna put here China. There's a purpose, right? So I'm gonna put 12. So it's gonna be let me incorporate Zambia 13, Mozo, Zambia 14. I'm gonna put Swangnam, Thailand. I put 15. I put Joshua, Vietnam. I noticed that I put the names more written, sorry. So you can put the names in the calculator. It will take time, so you can change that one. So now that's the things which we have. First point. All of you understand. Here is the thing. When you receive a data set, in most cases, you will never see the heading. Okay? There's no heading. It is up to you to ask, to understand the nature of the data. For example, you can ask, what does this mean? Is it serial number or it is registration number? You understand? What this mean? Is it a country? Because you may have let's say you have 20 columns, right? 20 columns. Here, it may, let's say, I just want to put one more here. Let's say I put here 3, let's say 3. I put here 4. I put here 4. I put here 2, or let's say 3. I put here, you add them because these are going to use them. Oh, no, that's 6, not Philippines. This is not. I put here, oops. I put here 4. I put here 3. I put here 4. I put here 5. Just let the highest be 5, right? So I put here 4, 5, 3, 4, 5, 3, and 2. Now let me put, okay, no problem. Let me put 2. Now, if you ask here, what could you say? If you have this data, we have this, we have this. So you need to know what is the heading of your data. Correct? To me, I designated, or I made this to be as rating. You understand? These are rating. For example, Joshua is rated 2 out of 5. This is rated 3 out of 5. 5 out of 5. You understand? And this one, I made them as serial number, not registration numbers. Serial number, right? Or you can call registration number. So you need to know. And this is the name, this is the country symbol. So now in a pig, we need to create this form. Okay? Remember, this is our data set. Data set is student. So I'm going to save it. Control X, Y, save. Okay? Control X, Y, save. Now, after saving this, I may cut student. So this is what I have. Next, I'm coming to my pig. Come to your pig, where we are, here. We are going to load our data set into pig. So what we do here, we say student data, and then we say load student, okay, load student using pig storage. This is the function which specify what separated comma do we use. It's a comma, right? We use a comma using this one as. Now we specify as what? Serial number, integer. We say last name, which is going to be card array, and we have country, which is card array type, and we have next, it's a rating, which is integer. Okay, this is it. We specify in this way. Remember, you need to know whatever you have. We have the serial number, we have the last name, we have the country, we have the rating as well. After this, we enter it. So it says duplicated. Okay, probably there's version there, but it's okay. There's no problem. Let's try to dump it. Dump means read. Okay, I put here. Dump. This is called dump. These are the operators. Okay, dump operator means it's like read. Okay, read or print on the screen. Okay, you want to print on the screen. All right. So I'm going to dump it. I say dump student data. So we dump whatever things we have there. So, oh, it has not taken any. Okay. Okay, let me give the location here and see, right? Student road again. Let's see. Down. Again 0. Home Hadoop. Let me check which version are we running here. Do we have the file there? Oh, I named as a Scott, right? I think I named as a Scott. Cat. Is that Scott? No. Student. Student? What is the student there? Where did I store it? Cat. I don't have a student there. So that's the problem there. So we need to check where did we create that one? Where did we create that one? So where did we create that one? Which area? Is it here? Very interesting. It is not here. Not here. Why did we create that file? Why did we create that file? We get the name as a student, right? Where? Where is it? Where is it? I'm not finding it.
Sure. I think the fire is not user.
Where is it? Is it inside? Where is it?
But you should make the fire on the first activity.
I created. Oh. Correct. You are very correct. It's maybe yes. CD. Yes. Now let me move from to. Let me first list it. Okay. Okay. Let me exit from here. Now let's. Okay, it's here. Thank you, Mr. Zudawe. So we created in a main, not in Hadoop. So I'm going to move there. Move student to home Hadoop. Sudo. All right. So I moved from here to there. Thank you. So the sudo. This, if it is a first, Mr. Songnam and Joshua, please. This we have learned in that class when we looked about Linux, right? Move, it is used in two ways: to rename, even to, to move a file from one location to another. This we moved from here. We are in Joe, for you can check, right? Not in Hadoop. We are in Joe user. So move from Joe user to Hadoop, where we are. So here I come back sudo su. All right, now I'm in here. I do ls. Now we have him here. Correct. Thanks. So we have him here. So we need to come back here. Where is our nano? Now we come here. We say pig x local. So we move this one here. Hopefully it will. Let me try the second one. Student rod. Oh, sorry, T is missing. Missing. It current number, last name, country. Let's see down. Student rod. Okay, it's rodded. So here, as you can see here, we have a student, they're rodded. And they're rodded in a form of list or tuples. Okay? They're rodded in a form of tuples. When we have a parenthesis like this, these are the tuples. Remember in a previous class, we saw that there are different types. We can have a dictionary, we can have a tuple, we can have These are the complex one. You can have integers, so we have a different types here. So this is the list of the students whom we have here. Next part, which is important. Let's say you want to store the student based on the country. Okay? You want to store the student based on their country or based on the nationalities which they may have. All right? So what you will do here is, for example, you want to group them by country. So you may say group student. I create one, and then I say group student road by, I'm going to mention by what? By country. All right? I will erase here for you can see now. This is what I did. I grouped the student by country. Okay? We use operator called group, and we take the file which we loaded, student, and by country here. Okay? By country. After this, you dump it. Let's say dump student dump group student. All right? So look now here. Look here, we have a China. How many we have? We have Jordan and the Zoo. Rwanda, Joe and Enowe. Right? Zambia, this. This is the key, this is the value is. Key, value we have. Myanmar, these are the one whom we have. Right? Indonesia, we have only one. So you can see them. Philippines, we have one. All right? This is the one we have. Now, for the continuity of what we shall see, whenever you do this, this is not the last. What you have to do, you need to store. Okay? You need to store this. This is the last. So what we do is as follows. Store, then we erase this one. Let's say erase. Say store group student into, let's say, home. Let's say home Hadoop output group. This is important. Okay? You can either end this by using specifying the, let's say you want to specify your comma or you want to specify the delimiter. If you don't want, you make like this way. Store group into that one. So total record written, the 10, right? Total byte written, none is there, right? So now look here. If you come to your home terminal, check here, and you do ls, you will see a folder called Pig student. Where is it? Home Hadoop. It's supposed to give us pig output. What is the pig output? Did you write? Okay. Come here. This is the last one. Let me mention only this one. Let me mention only the following. Sorry. Mention on output group 1. Total record 10. Total byte written. Now I come here. Okay, now it is here. Output group is here. You don't need to mention the path. Output group is here. Okay? Once again, ls, and you go cd output group, ls, you find this one. Okay, you find this part. If you read it, cut out, you find all the output which is stored there. This is your output. It will give this part one. It will partition them in this way. Okay, so you can find your storage here. China, Thailand, we have only one, so you have it as a file. We sorted, we made everything there in a P. Now we sorted it. All right, so in our next class, we shall continue from here. And please stop your demos. Stop all assets for a better way of storing, managing your file there. All right, so thank you. Until we meet in the next class.
Thank you, sir.
Thank you too.